Hello and welcome to our presentation for ENGE 2003 on sustainable energy. Introduction. In modern times, sustainable energy is widely accessible to a majority of people across the world. Although a majority of people around the world have access to sustainable energy, it is still not accessible to many people in different regions in the world, such as Africa. The director of the UK Energy Research Centre, Jim Watson, has discovered that the total number of people living off the energy systems in their daily lives is approximately 1.5 million people globally. Over the past several years, the world has been promoting the use of renewable energy resources rather than non-renewable energy resources such as fossil fuels. This is because of the many advantages renewable energy resources have, such as reducing carbon footprint and slowing down global warming. Although there are many advantages to renewable energy resources, there are still many disadvantages, with the prominent one being inconsistency in supply of energy when compared to fossil fuels and other energy resources. In this presentation, we will be talking about and going over the many resources accessible to humans in the present day and different aspects they contain. The aspects we will be comparing these energy resources to one another will be the average capital cost, the amount of money needed to implement these energy resources, such as cost for physical labor and cost for resources, and comparing the efficiency levels of each of these energy systems along with how sustainable they are. Our main goal is to figure out which energy system is the most sustainable and cost-friendly, so that is available to less developed regions of the world, such as Africa, that are in desperate need of sustainable energy.
Problem statement. The lack of modern energy storage systems in regions like Africa hinders the goal of providing reliable, sustainable, and cost-effective energy to communities worldwide. The inconsistency of renewable energy sources compared to fossil fuels presents a challenge. Feasible energy storage technologies need to be chosen while considering cost, efficiency, and available resources. The problem. The problem at hand is the limited access to modern energy systems, including energy storage systems, in regions such as Africa. Approximately 1.5 million people globally lack access to these systems, hindering the goal of extending reliable, sustainable, and cost-effective energy to communities worldwide. The world's focus on promoting renewable energy sources over fossil fuels emphasizes the importance of energy storage systems. My group and I aim to address the problem by discussing different types of energy storage technologies and comparing their average capital cost, total cost of implementation, including labor as well as resources, and energy efficiencies. The goal is to determine which energy systems can be feasibly implemented in regions like Africa, all while taking into consideration cost, efficiency, and available resources.
Compressed air plays a crucial role in addressing the inconsistencies related to renewable energy. The way it works is it harnesses excess electricity produced by renewable sources such as solar and wind power to compress air to high pressures. This highly pressurized air is then stored and can be used during periods of high electricity demand to spin a turbine. This turbine produces mechanical energy, which can then be converted into electricity that can be used in the electricity grid. Think of it similar to hydroelectricity, but instead of water spinning a turbine, it's this highly compressed air that was produced from the excess electricity. Another good thing about compressed air is that it's very versatile, as it can be used as an above-ground facility or underground storage system. The average capital cost is about $16 per kilowatt hour, with efficiency ranges from about 41 to 75%, making it a viable option for long-term energy storage. Hydrogen storage also works hand in hand with renewable sources such as solar and wind power to store excess energy. The way it works is it also uses excess electricity produced from these renewable sources to drive an electrochemical reaction with water, in which it splits water into its elements, hydrogen and oxygen. This hydrogen that is produced can then be stored in storage tanks and be used for later. It can be used to produce electricity. It can also be used in the gas sector and transportation sector. The capital cost for hydrogen is around $2 to $15 per kilowatt hour, making it quite cost effective. However, the efficiency stands at about 37.5%. Hydrogen has a lot of potential in the future, and with innovation, we can see that efficiency going up, making it a good option for the future.
Energy potential in Africa. Africa has a very high solar energy production potential at 1,360,000 terawatt hours. East, North, and Southern Africa have the highest solar energy potential combined at 905,000 terawatt hours. These regions have very high solar potential compared to other regions around the world, as seen in the map on the upper right. Western and Central Africa, however, have lower solar energy potentials due to a range of factors, yet solar is still promising in these regions. The continent also has a very promising potential for wind power at 460,000 terawatt hours. Compressed air storage systems should be implemented in Africa because they are compatible with Africa's wind and solar potentials, and they can maximize harvesting of Africa's renewable energy sources at a competitive cost and high efficiency. Further, compressed air systems are more versatile than hydrogen systems because air can be stored either above ground or below ground and requires less replacement than hydrogen storage. Although compressed air systems are efficient, small amounts of natural gas are used during compression, which means it's not a completely renewable method. However, reducing energy wastage far outweighs this drawback of using a minimal amount of natural gas. Our solution for energy storage systems is based off of capital cost, efficiency, and compatibility with the resources in Africa. Therefore, it is more of a solution for an ideal context. Real limitations to this solution exist, such as political factors, including government policies on energy rights and access to resources, social factors, the willingness of the people in these regions to adopt clean energy, and finally, economic factors beyond just capital costs, such as government funding and budgets set aside for clean energy developments. These three factors create a very complex dynamic of limitations in applying compressed air systems in Africa.
This research examined the efficiency, capital costs, and factors influencing the implementation of modern energy systems in Africa. Among the solutions explored, compressed systems emerged as the most viable option. Additionally, hydrogen storage showed promise for maximizing renewable energy production in this region. However, current limitations need to be addressed before its implementation can be utilized. These technological advancements play a crucial role in the shift towards renewable energy, ensuring energy conservation and distribution to meet demand. While these technologies meet economic and efficiency goals for feasibility in Africa, their application requires extensive consideration due to varying sociopolitical circumstances and budget constraints across the continent. Nonetheless, it remains essential to develop and implement these technologies to enable their future deployment in Africa and contribute to global sustainability goals.